Hello everybody, get ready to do lesson 2.5 for Algebra 2 Math, part 2 of 2.5. Apply the remainder and factor theorems. We have a 26-point skill sheet for classwork today, and we have a 4-point notebook entry today. I highly suggest that you get classwork sheets anyways, otherwise you're not going to know what's going on. Okay, so into our first example here for 2.5, example 2, using polynomial long division with a linear divisor. We have the situation here where we're going to divide that by this here, x minus 2. This would be our setup here. We're going to use like a long division format here. And x minus 2, x times x squared would be x cubed, so we start out with an x squared in our quotient, and then we multiply x squared times x minus 2, and we get this expression here, multiply divisor by x cubed. And so we have x cubed minus 2x squared, change signs, and then we subtract out here, multiply divisor by this, and then we subtract. So we have, we change our signs here. This becomes negative x cubed. This becomes positive 2x squared, so we have 7x squared. Then we drop down our negative 7x. Then x will go into 7x squared, 7x times our divisor now will be 7x squared minus 14x. Multiply divisor, and then we have this situation here. We change signs and add. This becomes negative, this becomes positive, and so 14x minus 7x will be 7x, and drop down there 2, and so x will go into 7x 7 times. 7 times x minus 2 would be 7x minus 14, change signs and add, remainder of 16 for that. So when we do that, we have a remainder of 16. And then what do we do with our remainder in this situation? We put it over x minus 2, our divisor. So when you divide this expression by this, you get this quotient here plus our remainder, 16 over x minus 2. That would be the way that you would divide this into this. Okay, divide using polynomial long division. We got this expression here. This is our divisor. Students, this is your situation down here. Pay attention so you can do your independent. We're going to use long division now. So this is our situation here. So we put this underneath the division bar here. Then there's our divisor. So x, how many times does x go into x cubed? It goes x squared. So x squared times x minus 1 is x cubed minus x squared. Change signs and add. So yeah, that's how we got that. That's how we got that. Change signs and add, and then when we add, we get 4x squared. We drop down our 3x here. How many times will x go into 4x squared? It'll go 4x times, will it not? Yes, it will. So 4x times x minus 1 would be 4x squared. Then 4x times negative 1 would be negative 4x. Change signs and add. So this becomes positive 4x plus 3x. That would be 7x. We drop down our 2. How many times will x go into 7x? It'll go 7 times, will it not? So we multiply 7 times x minus 1, get 7x minus 7, change signs and add. So we have a remainder of what, class? We have a remainder of 9. We combine these two, change signs and add. We have a remainder of 9. What do we do with the 9? We put it over our divisor. So here is our quotient here, x squared plus 4x plus 7 plus 9 over x minus 1. This is your answer to this division problem right here. Synthetic division If you use synthetic division to evaluate f of x in example 2 when x equals 2 as shown below, you can see that f of 2 equals the remainder when f of x is divided by x minus 2. Also, the other values below the line match the coefficients of the quotient. For this reason, synthetic division is sometimes called, or rather synthetic substitution, is sometimes called synthetic division. Synthetic division, and this is a classwork page, page 5 on your classwork. Synthetic division can be used to divide any polynomial by a divisor to form x minus k. So we can use this in a form of any polynomial by x minus k. So we got a situation here where we divided 2 into 1, 5, negative 7, and 2, and we get this situation here with a remainder of 16. I'm going to show you how to do this here, and this is way faster than doing it by division. So let's get into that. Key concept, remainder theorem. If a polynomial f of x divided by x minus k, then the remainder is r equals f of k. So it's a function of k. So let's get into a situation where we use synthetic division. We're going to divide this by this using synthetic division. So we have negative 3 here. This is the negative. This is our k here. So it'll be the negative k, be negative 3. And then these are the coefficients of this polynomial. Here, I'll put this in the top line here. 2, 1, negative 8, and 5 here. So what's our first step? We drop down to 2 is our first step. And then negative 3 times 2 is negative 6. We put that underneath here, change signs and add. Or we just add in this situation. We don't use the long division method here. We just add here. We don't change signs and add, we just add. So negative 6 and 1 would be negative 5. And then negative 3 times negative 5 is 15. Then we add and we get 7. Then negative 3 times 7 is negative 21. And then we add, and we get negative 16. So we have a situation here with a negative 16 as our remainder. So with this, the quotient for this division problem here is 2x squared minus 5x plus 7 minus 16 over x plus 3. That would be our solution to this division problem up here using synthetic division. Okay, let's use synthetic division here. Students, this is yours down here. Pay attention so you can do yours. Let's do our division in our guided practice. We got a situation there. Here are the coefficients of our dividend here. Here's our divisor. And what's the negative of 3? Be negative 3. So our first step here would be to drop down our 1. Then negative 3 times 1 is what? Negative 3, then we just add. We don't change signs or anything. We just add. That would be 1. And then again, multiply negative 3 times 1, and we would get negative 3. Let's add now. We get what? Negative 4. Negative 3 times negative 4 would be positive 12. And then we add, and what do we get? We get 11. So we get a remainder here of 11. X squared plus x minus 4. Yep. Then that's our remainder, and it goes over our divisor, x plus 3. So here is the quotient of this division problem there. That is lesson 2.5, part 2. Part 3 is available here. Thank you very much.